Okay, this video is about complex conjugates. When you're going to divide complex numbers, you need to find a conjugate of that complex number. It's really pretty simple to find. Let's say that my complex number is 4 plus 5i. The conjugate of that is still 4 with a 5i. It's just the opposite sign. If that's a plus, the conjugate has a minus. So it's 4 minus 5i. That's the conjugate of the original. So another example, if the original complex number was 3 minus 9i, the conjugate would be 3 plus 9i. And the reason we do that is to get rid of the imaginary parts, which when we FOIL it, that imaginary part will go away, which you'll see in the following examples. So to divide complex numbers, you have to follow these steps. First, find the conjugate of the denominator, just the denominator, like I just showed you. Then you're going to multiply the top and the bottom by the conjugate of the denominator. Then you would FOIL or box, you would multiply the two, and then reduce. Okay, so same steps, we're just going to do that on these examples. All right, first example, 2 plus 3i divided by 4 minus 2i. All right, so it said to find the conjugate of the denominator. Well, the conjugate would be 4 plus 2i. Then it says to multiply the top and the bottom by the conjugate of the denominator. Okay, so I don't care about the conjugate of the numerator, I'm only caring about the denominator. And here's why. Now we FOIL it and box it. All right, so let's FOIL the top, or you can box it, whatever you do. First terms would give me 8. Outer terms would give me plus 4i. Inner terms would give me plus 3i. Last terms would give me plus 6i squared. We'll reduce in a second, so just keep going. On the bottom, if I FOIL this, I get 16 plus 8i minus 8i minus 4i squared. All right, so we do some reducing. 8 plus 4i plus 3i is 7i, and this is 6 times negative 1. Denominator, 16 plus 8i minus 8i is 0. So what I really have here is 16 minus 4 times negative 1. So keep simplifying here. 8 plus 7i, 6 times negative 1 is minus 6. And I have 16 plus 4. So now what I have here is 2 plus 7i over 20. Okay, so there's my final answer. I can't reduce the 2 and the 20 because that 2 is being connected to the 7i. You cannot reduce just one part of that. Okay, lots of steps. You can do it. Try another one. So find the conjugate of the denominator, which is 2 plus I. Then I multiply that conjugate by the top and the bottom. Now I FOIL it. First terms, 4, outer, 2i, inner, 2i, last, I squared. Denominator. First, 4 plus outer, 2i, inner, negative 2i, last, negative I squared. Simplify. 4 plus 4i, I squared is a minus 1. Bottom, 4, 2i minus 2i, those are 0, minus a negative 1. All right, keep going. 4 minus 1 is a 3, plus 4i, all of that over, that's a 4 plus 1, which is a 5. So there's my solution to the division problem. All right, complex solutions. Here's what you need to do. You always want to take the I out of the radical first when you're multiplying radicals with negatives. We know that this is negative 1 times 3. We know that this is negative 1 times 12. Okay, I know you can keep factoring this, but let's just focus on the negative 1 first. So if I take out the I first, I have I square roots of 3 times I square roots of 12. All right? When I do that, I multiply outside to outside, inside to inside. So that's going to give me I squared times the square root of 3 times 12 is 36. So we know I squared is negative 1. We know the square root of 36 is 6. So my solution is a negative 6. If you just multiplied it, negative 3 times negative 12, you get a positive 36, and your answer would be incorrect because you would think it's just a positive 6, but it's not. You have to take the I, the imaginary part, out first. All right, look at this complex solution. Negative 1 plus the square root of 3. All right, so negative 1 plus the square root of 3 squared, which means I have to multiply it by itself. FOIL or box it. Negative 1 times negative 1 is 1. Negative 1 square roots of 3. Outer, inner, and last. Square root of 3 times square root of 3 is the square root of 9. Okay, let's simplify. 1 minus 2 square roots of 3. These are like terms because they have the same radical. Plus square root of 9 is 3. Combine like terms, I get 4 minus 2 square roots of 3. All right, sometimes when you need to solve, you're not going to be able to just factor. You have to use the quadratic formula. And sometimes we have imaginary solutions here. So we're going to walk through quadratic formula like we have before. A is a 3, B is negative 2, C is 5. All right, so we plug in our values just like before. So if B is negative 2, negative B is a positive 2, plus or minus. B squared, negative 2 squared, minus 4 times A times C. All of that over 2 times A. Okay, so let's reduce and simplify. Negative 2 squared is 4, minus 4 times 3 is 12. 12 times 5 is 60. Okay, on the bottom, I'm going to have a 6. All right, keep reducing. 2 plus or minus 4 minus 60 is negative 56. All right, now, let's talk about negative 56. Let's factor this. Remember, I'm going to take out a negative 1, and then it's 8 times 7. That factors to 2 and a 4. Okay, so here are my factors. 2 and 2. Okay, remember, if there's 2 of the same, you can take them out. Square root of that negative 1 is I. We can take this out, right? So what I've reduced this to is now what I can take out is an I, and I can take out a 2. So it's 2I, square root of what's left inside. What's left inside? Of 14. All of that over 6. Now, all these terms are even, so I can factor out a 2. That'll leave me with 1 plus or minus I square roots of 14 over 6. These will reduce, so I've got 1 plus or minus I square roots of 14 over 3. So my two solutions are 1 plus I square roots of 14 over 3, comma 0, and 1 minus I square roots of 14 over 3, comma 0. So yeah, the solutions are long, but you can do it. You just have an I now, and you know how to use that. All right, for the whisk, I want you to divide this. Remember the steps. Find the conjugate of the denominator, multiply the top and bottom by the conjugate of the denominator, and then simplify. Good luck, and write your answer in the whisk so I can see how you're doing.